Hello everyone, this is Jeff Eckstein with Festo. In today's video, I'm going to guide you through commissioning a Festo SMS actuator into an Allen Bradley Compact Logix PLC. We're going to be taking advantage of the IOLink technology built into the Festo SMS actuator. So we'll be using an Allen Bradley 5032 ArmorBlock IOLink Master to do that. In the video today, we're going to go through setting up the IP address of the IOLink Master, and then we'll create a brand new project in Studio 5000, and we'll write some simple code and start commanding our actuator. Let's start out by taking a look at the hardware we're using in today's video. If you notice in the bottom right hand of your screen, you'll see our hardware layout. Starting at the top left of that layout, you'll see our single phase 24 volt 10 amp power supply from Phoenix Contact. That can be ordered through Festo's website. Directly to the right of that, you'll see a Compact Logix PLC. That's a 5069 L306 ERMS2. And then to the right of that, you'll see our 5032 8IOL IOLink Master from Allen Bradley. And then lastly, at the bottom of the screen, you'll see our SMS actuator. This one happens to be an ELGS-TV tooth belt actuator from Festo, and this one's a 200mm stroke. The software we're going to be using in today's video is Studio 5000, version 35. Let's go ahead and start out by setting the IP address of the IOLink Master. That can be done by using the dip switches on the front of the IOLink Master. If you refer to the manual, the dip switches come in a 999 position by default. The default subnet is 192.168.1, and then the last octet of that address will be whatever your dip switches are. So we're going to go ahead and switch our view over to our hardware, and I'm going to go ahead and set my dip switches to the appropriate address. So we're going to start by removing power from the device. Then we're going to remove the cover on the dip switches. That's just a quarter turn, and then it simply comes out. And we're going to set our dip switches to 0, 0, 5, and then reapply power. So what we've done there is just set our IP address to 192.168.1.5. So we'll go ahead and flip back over to our screen here. One thing I want to point out real quick is there is browser requirements for this IOLink Master. These are the requirements listed: Microsoft Edge, Google Chrome, or Firefox with these versions or newer. But I will tell you that I tried Microsoft Edge, and I did have a newer version than 1.16, and I was unsuccessful with launching the web server. So I downloaded Firefox, and that seemed to work pretty well. So make sure your local computer IP address is set to the same subnet, and we're going to go ahead and launch Firefox and type in our address, 192.168.1.5. And this comes up the first time you launch the web server, so just accept the risk and continue on, and this will let us into the web server. So the very first time you log into the web server, it forces you to change the password. So the username is admin. The default password out of the box is password, all lowercase. And then just create a new password, whatever you desire. It has to be minimum 8 characters. So I'm just going to call mine ELGS TV SMS. And then we'll set that password. So we can go ahead and hit continue here. All right, so we are on the web server now, but we are actually still not logged in. There's another menu here that will not appear until you log in. So I'm going to go ahead and sign in using the credentials I just created for admin. Sorry. Then we'll go ahead and sign in. All right, and you'll see we got this configuration tab that showed up after I signed in. So if we expand that configuration tab and go to Internet Protocol, we're going to leave this on the rotary switch, and we're just going to update our address to our desired address. And for me, I'm just going to change the third octet of the subnet to 100, because that's what my PLC is set to. And then I'm going to go ahead and just click Apply. All right, once we're done with that, we're pretty much done with the web server. Everything else can be done in the PLC program. So I'm going to go ahead and just change my IP address back to that 100 subnet. And then we'll go ahead and open up a brand new project in Studio 5000. So pick the appropriate PLC and then give it a name. We'll just call this SMS Demo. And then again, I'm working in version 35, so we'll set the appropriate revision, and then go ahead and create this project. Okay, now that we're in the project, this is, again, just a brand new project. The PLC out of the box is configured with dual IP, so just make sure you are configuring the correct Ethernet module on your PLC. For us, it's A1. That's going to be our local area network. We're going to go ahead and just right-click on that and say New Module. And we're going to add our 5032 8 IOL master. So we'll just search for 5032 8 IOL M12DR. That's the module I have. And we're going to go ahead and create that. And we will name this Master 1, just in case we have multiples. And we're going to go ahead and define our IP address as 192.168.100.5. And then while we're in here, we're going to go ahead and go to the module definition, and we're going to just enable our first channel to IOLink, because that's what our SMS actuator is going to be connected to. So we'll go ahead and just enable that now. We could do it after the fact, no problem. It looks like that should be all we need for that. So just click OK, and you'll see that we added that down in our Ethernet tree down there. You can go and close this out. So something to be aware of is there is a hardware limitation on the new 5032 ArmorBlock series IO modules. So if you have like an L16 processor, you won't be able to use the new 5032 ArmorBlock series. So there is a hardware limitation. Just refer to the manual to figure out what that is. But we are good on our 5069 L306 for sure. All right, the next thing we need to do is we need to go find our IODD file for our ELGS SMS actuator. So we can do that by going to Festo's website. And we're just going to go to www.festo.com/US. And then once we get in here, we're going to type in the part number of our SMS actuator. So for our specific one, it's 8083665. And we'll just go show details on that item there. And once we're in here, we need to click the Downloads tab and go to Software. And then you see our IOLink IODD file here. So we're going to go ahead and download that file. And then we'll go and zip that file in our Downloads folder. Perfect. And then we can close out of all of these. And then from Studio 5000, we'll go up to the Tools tab here and go to EDS Hardware Installation. And then just follow the prompts here. We're going to register a new device, yes. We're going to browse for our file, and we'll just browse to our downloads and go to that EDS file. And there's one in German and one in English, so we're going to choose the one in English. And then next, next. Again, just keep following the prompts, and then finish. So once that EDS IODD file has been installed, now we can search for our IOLink device. So basically, just click on the IOLink insignia right here, and then right-click New Module. And since the only Festo device is going to be from that IODD file, I'm just going to search via typing in Festo, and we'll see our ELGS TB actuator here. So we'll just go ahead and add that, and we're going to name this SMS. We'll go ahead and just click OK, and we'll see that that actuator has been added there. So at this point, we have the bare minimum we would need in this project. So I'm going to go ahead and connect and download to our PLC. And this is my PLC right here, this 192.168.100.20. So we'll go ahead and select that item and download this project. And then we'll put the controller in run mode. And once we get to this state here, I always like to take a look at my IO not responding indicator up here. And you notice it's flashing, so something's not talking here. If I come down and look, it looks like the master is connected, but my ELGS is not connected. So I'm just going to flip over to my hardware view here real quick. I had my IOLink ELGS unplugged from my IOLink Master, just so I can hit those rotary switches a little easier. So I'm going to go and plug this back in. And then we'll go see if that fixes our connection issue over here. And it looks like it did. It looks like we're talking. Everything should be good there. So we need to write a little bit of code in our project so we can start commanding this SMS actuator. But before we do that, I want to show you guys the controller tags that were created based off of this IOLink Master and integrating our IODD file and all this stuff down here. So what that did was basically created this group of tags here for my SMS actuator based on the name that I gave this IOLink device down here, SMS. And then my master has its data right here. But we're not going to be too concerned about the IOLink master data. We're more concerned about the device data here. So I want to just open up my input data here. And if you come down and look at process data in, this is the data, the process data from our SMS actuator. So it's a very small, limited group of data. The SMS actuator was intended to be a pneumatic replacement. So it essentially is going to give you the same feedback that you would get from a pneumatic cylinder with reed switches on both ends. So you will get position feedback whether you're in, out, or there's an intermediate position that we can use with our IOLink SMS. And then you'll get the state of the device and whether the device is currently moving or not. So that's pretty much it for process data. There is some extended input functionality here because of the Allen Bradley integration. So if you look at our SMS output tag here and go to process data out, you'll see a very limited amount of process data output here as well. So we can tell the SMS actuator to move in, out, or intermediate, and then we can tell it to quit air or reset air. But the big kicker here with the new 5032 ArmorBlock IOLink Master, because it's an Allen Bradley piece of hardware getting integrated into an Allen Bradley piece of hardware, they have a little bit more control over some of the communication protocols between their devices. So if you open up the configuration tag here, this is typically has to be set up with like an explicit messaging instruction if you're using a different IOLink master. But with this master in the configuration tag, you'll see that we have some positional information here, like our intermediate position. We can write our intermediate position or our out position or our start press. We can also write our speeds in and out and our force that we want to apply to our pressing move. So all this information is in this configuration tag. The problem is if I just change this tag, it doesn't do anything. The device doesn't react to these tags. So I'm going to show you a really cool, simple way to add some data into this configuration group of configuration tags and then write it all in one message instruction. So that's what we're going to focus on today. So let's go to our main routine here, and I'll show you an example of what I was just talking about. So we're just going to put a contact in here and then a message instruction. So we'll do XIC and MSG. And we're just going to create a tag for this. We'll maybe call it SMS config. And then just create this message instruction. And then we'll call this test bit. And then create that as well. We'll create this as a dent. So we have a bunch of test bits if we want them. And then just have that one be 0. All right, now let's open up this message instruction so we can configure this. You guys can see how simple this is. Typically, you got a specific service code and class number for the specific area you're trying to locate in a group of data. And then once you get to that device, you have to define where you're going inside that device to find the instance number and attribute. And there's quite a bit that goes into this and a lot of documentation you got to read through. But with this setup, instead of being a message type of SIP generic, we're just going to be a module reconfig. And you see that it takes all those parameters away. So there's no other parameters I need to fill in. I just need to create a message instruction called module reconfig. I need to point to the device that I want to reconfig. And in our instance, that's going to be our SMS actuator. So we just select that item there. And that's it. Literally, we can just hit apply and OK. And we can assemble this very simple rung here. And basically what this is going to do is if we go back to my tags here, if I change my speed to 1 means 10%, so 10 would mean 100% of speed. So if I change these all to 10, even my force, I just want to do 100% force. So I change all 3 of those, and then I run this message instruction. It's going to write those values to my device. So if I check my properties here of my SMS actuator, so go to configuration, you'll see that my speed out, speed in, and my force are all now at 100. And you see my start press position, my out position, and my intermediate, they're still at 0s. So if I try to make a move right now, it's not going to go anywhere because all my commanded positions are at 0. So let's go back to our configuration tags and let's just make our out position. We have a 200 millimeter actuator, so let's just make it 200 millimeters. And then we'll go back to our routine here and we'll write that data. And then let's go back to our module properties and you can see that our end out position is at 200. Now the reason I wrote a 20,000 in there is the decimal point is moved 2 places to the right between the data in the PLC and the data that the device is expecting. So you just add 2 zeros on the value you're trying to write. So if you want to go 200 millimeters, just add 2 zeros on the end of it. Like I said, for our speed in, it's move the decimal place 1 position to the left. So just things to keep in mind. So speed at 10 is actually 100, and position at 20,000 is actually 200. So let's go ahead. Our start press position needs to be the same as our out position. Otherwise, it's going to be in a pressing force control mode the entire time it's moving out. So let's just change that value and just go run this message instruction again and see that it went done. And let's check our module properties so we can see here that our press and our out position are both set to 200. So that's great. So let's go to, remember I was showing you our process data. So here's our process data out. So if I want to tell this thing to move out, I can simply just force a 1 into this tag here and get my actuator to move out. It looks like my actuator is faulted right now, so I'm just going to go ahead and reset the fault. And then we'll tell it to move out. And my actuator just moved out. So I'm going to go ahead and switch my view so you guys can see the actuator making some movement. So I'm just going to force a 1 into the move in tag. And you can see my actuator moved in at a speed of 100% with 100% force. And let's go ahead and move to the intermediate position, which I don't have any value in yet. So let me put some value in our intermediate position real quick, maybe 100 millimeters. And then we'll write that value. And then I'll move to intermediate. So that's our intermediate position. And then here's our out position. And so on and so forth. Here's our in position. So let's go ahead and fly back to our PLC program real quick. So what I'm going to do here, just to make things a little simpler, is I'm going to import some rungs of code that I've already configured in a different program. So that should be here. So we got these 3. Let's go ahead and import these. And I'll show you kind of how I set up a little sample project here. Get rid of that run there, and I'm going to go ahead and import one more as well. We're going to go a little more detail on some other things there that can be done. Okay, so we obviously have 2 message instructions now, but that's fine. It doesn't matter. They have 2 different names. So I'm just going to leave everything like it is. We'll go ahead and assemble this. These rungs here, and then let's take a look at what we got here. So what I brought in was basically the same message instruction that we just created up here with a different name. No big deal. I'm going to go ahead and make this one test bit 31, just so it's out of the way. It doesn't toggle when the other one toggles. So what we've done here is just test bit message instruction that's configured exactly how we just configured that other one. It's set to communicate with my SMS. And then we got another test bit here where we're moving the speed for my in, out, and my force. We're moving all that data into the configuration tag. So this is just a tag I created, and this is the configuration tag of the SMS actuator. So we're just moving that data in. So we can change these values if we want them to match right now what's actually in the device. We just change them so they're all 10. And then if you see down here, we have our 3 major positions that we're worried about: our start press position, our out, and our intermediate. So you can see what our configuration tag has in it right now, and then you can see what our end out position is and our start press position. So if we wanted to change these, what I've noticed is if you try to change all 3 of these positions and then write this message instruction, it doesn't tend to work with all that data moving in one message instruction. So I recommend doing these one at a time. So like the start press position, we'll do that one real quick. We'll move that from 200 millimeters to 150 millimeters. And then let's go write this instruction, and you can see that it went done. So now when I move to my out position, I'm going to flop my view here real quick. When I move to my out position, I'm going to, at 150 millimeters, I'm going to start my torque mode or my force control mode and start the pressing for 50 millimeters basically, because we're going from 150 to 200 in torque mode. So let's go ahead and move to the out state. And then you see that last 50 millimeters, I'm in force control mode, where my force is set to 100%, so it's going to be very hard to stop that actuator. But you get the point. So we'll move back in and then move back out, and you'll see that at 150, we start our force control. That's a pretty cool feature. Let's flop back here. Let's move our force to, instead of being at 100%, let's put this at like 20. And we'll move that data into our configuration tag. Then we'll write it to the device through this message instruction. And then we'll go ahead and just move out. Oops, sorry, we're already out. We'll move in and then move back out. And I can see it's moving. So we'll move back in. I'll change the view over for you guys. What I'm going to do is move out, and I'm going to grab this actuator with my hand and stop it from moving. So you can see that I can stop this from moving. It's at a 20% of the total force that this actuator can apply. That's what it's at right now. Now, anytime I let go of it, it's still going to go for that target move of 200. That's our out position. That's our target move. So that's a pretty cool feature. And then I also want to show you back here on the PLC program, you know, I put our device state in here. So when I tell it to move out, I'm just going to move until it's in the out position. So when I move in, it's only going to move there until we're in that position. Then I can toggle that bit back off. So just with this configuration tag in the ArmorBlock IOLink Master, just with this setup with the configuration tags, you have a lot of control over the SMS actuator that you wouldn't otherwise have without doing message instructions. So this makes it very nice. You're still doing a message instruction, but it's a very simplistic setup on it, as you can see. So I do want to show you one more thing real quick. I know this video is getting to be a little bit long, but we've had a couple of customers ask us, you know, well, this is great, all this is nice, and you can do this very easy with the new ArmorBlock IOLink Master, but where do I see my actual position of the actuator? So that is not one of the tags that's in the configuration, your actual position. So I just wrote a quick routine here to do an explicit read message from the IOLink Master down to our device to get this information. So I want to show you guys how this is set up real quick. So I'm just going to turn this test bit on, and we're basically just doing a 100 millisecond cycle rate on this message instruction, and we're reading the value of the actual position, but that value is coming over, and we need to reverse the byte order for it to read the number that we want to read. So I will real quickly, I'll show you how this message instruction is set up, and then I'll bounce over to our manual and show you where I got the information to make this happen. But you can kind of see what we're doing here. We just got a 100 millisecond cycle timer, our message instruction. We're moving that data into itself just for me to view, so I can see what that data is. And then we have a swap byte instruction through Rockwell here. And basically what we're doing is we're taking the DINT, the double integer value, and we're swapping the order that we're reading. Instead of reading it from bit 0 through bit 31, we're reading it bit 31 through 0. We're swapping that byte order. And what that does is gives us this value here, from this value to this value. Then we need to take the new value that we have and multiply by 0.01 to get our actual positional value. So if I do a move out real quick, and remember my move out is set to end out position is at 200 millimeters. So let's go ahead and do move out. And you can see that I'm at 200 millimeters. Now this is a little slow because obviously I'm just doing a 100 millisecond cycle here on my read. So this will be a little slow, but you can see that it's reading our actual position. Now another thing to keep in mind too is the SMS actuator is not a high precision actuator. It's, I think in the manual we say up to 0.2 of a millimeter accuracy. So there will be some fluctuation. This is a stepper motor. You know, the intention for this actuator is to be a pneumatic replacement. So you will see a little variance here in your actual position versus your commanded, but we're talking fractions of a millimeter. So it's still very, very impressive for what it is. So let's take a look at this message instruction real quick, and I'll show you how I configured this and how I got this information. So basically this is just a generic service type custom. Again, the service code and the class, that information comes from Allen Bradley's manual on this IOLink Master. That's where that information comes from. And then the instance and attribute, that would be the index and sub-index number. That information comes from Festo's manual. So we're going to bounce to those manuals real quick so I can show you where I found this information. So if you see here on the ArmorBlock user manual, under this is page 95 for explicit messaging, for reading and writing, you can see here that my service code is 32 for a raw get attribute, so a read, and then 33 for a set or a write. So if we bounce back to our PLC project, you will see that 32 is read and 33 would be write. So if I wanted to make a message instruction and write some data to a parameter on the SMS actuator, this would just be 33 and the class would still be 10B. Let's bounce back to that manual real quick. Furthermore, if you scroll down here a little bit more, you'll see the instructions on configuring an IOLink device through the configuration tags. And that's what we've done with that one message instruction. It shows you how to set that up here as well. So let's take a look at the ELGS actuator manual. And you'll see here, this is where I found the index number for current position. And that is, this is the hex value here, and this is the decimal value. So the message instruction is looking for a decimal value of 288, and the sub-index is 0 because there is no sub-index. It's just an index location. Some parameters require index and sub-index, so you'll have a value on both of these. And then obviously, if you've set up message instructions before, you just need your data for your source and destination element. When you're doing a read, the source length just gets set to 0. You just need to make sure that your destination element is large enough to receive the data you're reading. So that's basically how I set this message instruction up, and that allows me to get actual position. So between the configuration tags and this one message read instruction, I have some pretty good control over this SMS actuator all through an IOLink port on the ArmorBlock IOLink Master. So hopefully this helps you get moving and get to a good position on your Festo SMS actuator. And thanks for watching. We'll see you next time.